Welcome back. Today in chapter 8 of this series, we will learn how to display data in SQL Server. We will cover select, where, group by, and having clause. We will also learn different techniques to search data from millions of rows. Let's start. First of all, we need to connect to our server. Go to databases, expand that. This is the clinical system database we created in our previous chapters. Then under this clinical system database, we are going to expand tables. And this is the list of tables we created for our exercises. Okay, so let's start with new query. To display the data from one of the tables, we will start typing the code. The first word we type is called select. This is the most common word you will be using on your SQL journey. The next most common character is called asterisk. How you can type that on your keyboard, press shift and number 8. Select all, then you need to type from, then you need to provide name of the table. From our list of the tables, for example, we want to look the data from dim pat, so we type dim and pat. So either we can press F5 from our keyboard or we can execute from here. So if we execute that, right, so what happened here? This is an error. It says invalid object name dimpat. Why it is saying invalid object name is because it could not recognize what dimpat means. The reason for that is dimpat is a table, but table always come with a schema. We did not put the schema in front of the table, so that's why it is displaying this error. What we can do is we can type the name of the schema in front of the table name, dbo dimpat. Try again. Oh, it didn't work again. Although we provided the schema, but still it did not work. Okay, so what we can do is we need to select the correct database from the drop down, and then if we run now, it has worked. The other method is delete that, and we can drag our table name and drop there, and then we can select, and then we can execute that. The third method is we can go to our Object Explorer window, select the table we are interested in, right click it, and then option number 3 is select top 1000 rows. Click that, and then it is displaying all the columns of the table, and it is displaying the data at the bottom. The fourth method to display the data from a table is right click the table again, right click the table, script to, then select to, new query editor window, and then you can execute that, and this is how you can display the data on your screen. Both method 3 and 4 are commonly used to display the data from a SQL table, especially when the name of the table is not quick to type. There is an important point to remember. If you try to run this code when we only entered without the schema like that, if you remember that it worked, but it was our database selected was master. If we run it again, it is throwing an error. So there are two ways to deal with this. One method is either we type the name of the database on top of our code, use, and then we drag and drop the name of our database. When we will execute this code, the SQL Server will know we are trying to access dimpat table from clinical system database. So we execute that, so it worked. Or the other thing we can do is what I did earlier. If we don't want to do that, delete that, we can select the correct database from that drop down. To avoid that error, the best practice is always provide the fully qualified name, and that is select all from, first of all, we will type the name of the database. The name of the database is clinical system, then dot. The next thing is name of the schema. The schema is DBO. What is schema? We will discuss schema in our upcoming chapters. After schema, we will provide the name of our table. So this is called fully qualified name. Even if master database is selected, master database is one of the system databases which we talked about in our previous chapters. So if I run this code now, it will work because we have provided fully qualified name. First part is name of the database, name of the schema, and then name of the table. This practice will be very, very useful when you are going to join more than one tables and display the data. It will be very helpful if the data is coming from different databases. Then you will realize it will make your life very easy. Sometimes we need to look at the unique rows of data, and it can be very difficult to pick up unique rows. If we are working with large tables with millions of rows, but it is possible by adding distinct to our query. Okay, so at the moment we are only running select all from that. Next thing we need to do is delete that part, and then we can type distinct, and then we need to provide the name of the table. So on this instance we are going to use clinical system database, then schema name. After the schema we will be using our fact proc. Let's see what's inside here without the distinct. Just select all the columns, execute that. So we have 30 rows showing in this table. What if we are only interested in pat ID? So we can write pat ID, and then if we run it now, it will only display the column we entered here, pat ID. If we are interested in other columns, then we can add those columns, star, other than pat ID. Let's copy this, that will be easier for us. Go there. In here we can select those columns we are interested in. The first one was pat ID. The second column we might be interested in the cost code. Now if we run this part, it will display our two columns, and so on. If we are interested in more columns, you can keep adding those columns and you can see only data for those columns. At the moment it is displaying the data for all the columns, but for following code it is only displaying the data for only two columns. Right, so we were talking about distinct. So if we want to look at the distinct data, we can, so the data we want to look at distinct is probably for the proc type. So we type distinct and then we type proc type. Right, so if I run this, as you can see on your screen, you are seeing only one column of data, which is proc type, but there are only two rows. First one is diagnostic and second one is surgery. What if we type this code again? Let's copy this and paste again. On this occasion, we delete the word distinct, and then if we run this code, right, now it is showing 30 rows, and all those rows are either surgery or diagnostics. So the difference between using distinct is it will only display the distinct rows. We are working with a very small set of data. Our rows are we are working only with 30 rows, and from these 30 rows we can just scroll it down, and then we can see this diagnostic and surgery, and we can look at distinct rows. But the easiest way to do it is type distinct before the column name, and then you can execute that, and it will provide the result in a second. Because this is a very small data we are working on, we can even use scroll bar. But what if you are working with millions of rows? Then it is not possible to keep scrolling those millions of rows and try to find the unique set of information. So for that, this distinct is a game changer. It will provide you the distinct rows in a few seconds. Well, there will be times when you need unique set of data for more than one column. Is it possible? Of course it is. Let's try this. So we were looking at proc type. Now we add another field to it. Okay, let's see which are our fields. So we tried proc type. We can add proc description. So we add proc description, and if we run this again, you can see there are again 30 rows. Proc type is repeating either surgery or diagnostic, but proc description, there are different type of procedures have gone under proc description. What if we copy proc description and then add to our distinct query, run it again? Well, it has shrunk the data to only 10 rows. So if we run distinct only on one column, there are only 2 rows, diagnostic and surgery. But when we added proc description, there are 10 unique rows, because under diagnostic, that's angioplasty, diagnostic scan, under diagnostic is liver biopsy. But when we look at surgery, there are 1, 2, 3, 4, 5, 6, 7 unique rows that goes under surgery. So this is how we can look at distinct set of rows. We can add further columns to this, and it will keep displaying the data on the unique set of rows according to the data in the table. Next, let's have a look at the filtering option. Delete that code. Start typing in, select all from clinical system database, schema, then name of the table. Right, okay. So we execute this. We have 21 rows of data in our DIMPAT table. To use the filtering, let's look at with an example. If you are interested to know which patient is from Japan, to do that, we type where. So Japan will be in the country column. So we type country, and then we say equal to Japan. If we are providing any text data, is also called string, we provide in apostrophes. So if we select and run this code, okay, so this patient is from Japan. This is how we can find out if the patient is from Japan. This is our filtering option. But if you want to know which patients are from Japan, Turkey, Ireland, and Palestine, so how you can do that? You need to change this where country, This time we will not use equal to sign, but instead we will say in, and we do put the names in brackets. So start with Japan, then add a comma, the next country name, that was, let's say, Turkey, then say Ireland and Palestine. So if we run this now, so these are the patients from Palestine, Turkey, Ireland and Japan. What if you forgot a patient's name but only remember that the first letter starts with B? So for that we will use a wildcard. Okay, delete that part, and we are going to find a patient. Their name starts with B. Okay, so we'll say where we can either use forename or surname. Let's do forename. Forename. Now we will use word like, because we don't know the exact letters. If we know the exact letters, we can use in or equal to sign, but because we are not sure, we will use a wildcard, and wildcard works with like operator. Like. Now we will give the first character, which we know, but we are not sure the rest of the characters. For that we will use a percentage sign, which you can do that by pressing Shift key with number 5, and then we close this. And now if you run, so there are 3 patients, Becky, Boris and Brad. So these ones we can see their name starts with B. Let's try this in a different way. If we need to look for a patient with letter Z in their surnames, letter Z can be anywhere in the surname. It can be in the beginning of it, in the middle, or in the end. So what we can do, let's change this forename to surname. Then we keep the like, but now what we need to do, we need to put the percentage sign first, because we are not sure whether the name starts with the Z or it's in the middle or at the end. So we put Z after the percentage sign, and then we need to provide another percentage sign. If we run this code now, so these 3 people, their name have Z in it. Zidane starts with Z, the 0, the Z in the middle, and the Zaprio is also Z in the middle. So this is how we can find out if we are not sure whether the character is in the beginning, middle or at the end. There is another way we can use wildcard. We can try to find patients who live in a country that ends with letter A. So let's do that. Delete the surname, write country and leave like that. And now what we need to do, we need to put the percentage sign first, because we are not sure what the first character will be. So we only add A because that's the last character. And then if we execute that now, you can see these countries end with A, like Canada, Nigeria, Australia, China, USA, India and Indonesia. We just covered 3 ways of using a wildcard. Let's move on and look at different operators that are used in SQL Server. Right, so the next example we will look at is list of all the patients apart from those who live in Spain. Okay, so we leave the country as it is, but now because we don't want anybody from Spain, so we know the patients are not from Spain, so we will use not equal to. Before that we used equal to sign when we were looking for a patient from Japan, but this is called not equal to, and then we type the name Spain. If we run it again, so it will provide the list of all the other countries but excluding Spain. As you can see, Spain is not listed. Or next example we look at is list of patients who are not from Australia, China, Iran, Pakistan and Italy. So for that we will not use not equal to sign. Instead we will use, if you remember previously we used in operator, but because this time we don't want the data from these countries, we will use not in, and then we'll provide the list of the countries. Let's close the bracket first, and inside we will start typing the name of the countries. Australia. Next one is China, then Iran, Pakistan, Mr. P, okay, and the last is Italy. So if we run it now, it will provide the list of all of the countries apart from the countries we listed in our code: Australia, China, Iran, Pakistan and Italy. So those countries are not listed. Now look at the patients who are older than 50 years of age. So we are going to use a different operator. Delete this part, and then now we are looking at age, and if we want to find out patients who are older than 50, so if we use this character, this means greater than, you can achieve that by holding down the shift key, and then on your keyboard next to the shift key there is a dot or decimal. If you use with the shift key, it will enter this greater than sign. Now if you type number 50, run it again, as you can see in the age column you will not see anybody who is less than 50. So the minimum we have is 54. So this is how we can do that. Now let's have a look at the patients who are younger than 40 years of age. So this is our greater than sign. Next to our greater than on the keyboard we have less than sign. We type less than again with using shift key, and this time we are using number 40. So any patient who is younger than 40 years of age, execute, and on your screen you can see the oldest is 38 years, which is still less than 40. So this is how we can achieve that. Now let's look at another example. List of patients younger than 46. So if we want to look at younger than 46, we try to use a different operator this time. We are not, either we can use less than 46, but just to give you an idea how many different operators are there and how we can use them, I'm going to use a different operator. So this time I'm going to say less than and then equal to. So we can use less than and equal to at same time, and I can provide the number 45. So just run this one again. So these patients are less than 46 years of age. So anybody who is 45 or less than 45, they will display. So we have one of the patients 45 years of age showing here. Right, so after that Let's look at another example. What if we want to find out a list of patients where the age is 71 and older? So we can use a similar operator again. We can use greater than and then equal to 71. So if we run this code, you can see all these patients are 71 and older. The youngest one is 71. After that, we are going to look at another operator which is also very useful with an example. What if we are interested to know the list of patients where the age is between 40 and 60, right? So we have tried equal to, greater than, lower than, less than, but now we are going to use between. So age between, we can type 40 and 60. So anybody who is between 40 and 60 years of age should display on our screen. So as you can see, all these patients are between 40 and 60 years of age. Right, after that, let's look at the patients who live in countries whose names start with, we can just pick any of the characters. Let's start typing. So we are looking at countries. Country this is the first method we are going to use. So we are looking at either we can go the long way, which is type all the names. Canada. What other countries are there? Iran. Then there might be Indonesia. Then let's say China. Italy. Then India. It's taking a while to type all these names. Germany. And then the reason I'm doing that is I'm going to show you a smartest way to look at the same results after this. So if you execute this, so we are looking at Canada, Italy, Germany, China, Iran, India, Ireland, and Indonesia. So it took us a while to enter all these names. There is another way of achieving that, and that'll be much quicker. Select all. Let's copy this and paste. Control C and Control V, and then we say where country. Rather than using in or providing the exact name of the countries, we will use another operator, and that is like. Then because it's a string characters, we start with apostrophes, and then in these brackets we will provide, if you look at the name of the countries, they start with C, I, and G. C, I, and G, yeah. So we put C, G, I, these three, and after the bracket we give the percentage sign. So we know the names start with either C, G, or I, but the rest of the characters can be any of the characters. So if we type this, typing these 1, 2, 3, 4, 5, 6, these 6 characters only takes probably 6 seconds, and if we run that, so make a note of the number of rows, 8 rows. If we execute this, again, you can see these are 8 rows. So if we run that, same number of rows, 8, but this is a smarter way of executing the same code, is like that. Right, let's try to use another operator. This code will display all the patients who don't live in those countries. Okay, so if we copy this, first of all, if you want to do it the longer way, you can type here not in, and then if you run this, then you will see there are 13 countries other than Canada, Iran, Indonesia, China, Italy, India, Germany, and Ireland. But the other way, we can use this code that takes less time. Only thing you need to do is type this character here. After typing that, you can achieve that by holding down the shift key and press number 6. And if we run this, there are 13 countries. And if we run our code above, that's also 13 countries. So this is a quick and easy way of doing it using these operators. Well, the next thing we will learn is called group by clause. Let's clear our screen, start typing select all from name of the database, name of the schema, and name of the table. Right, okay, so we have 21 rows of the data. The thing we are going to use is called group by. Before I type group by, I want to show you another thing is if I copy this code again, and then if I use distinct clause, which we used before, distinct, and let's say we are interested in title of the patient and gender of the patient. Okay, so title, okay, that's a mess. Typo, title. Right, okay. So we have either male or female in gender column, and we have Miss, Mr. and Mrs. in our title column. So this is how we can find out the unique rows in our table. But then I'm going to show you another way. Select, just copy these two columns, type it here, and then copy the table name, paste it there. What if we don't use the distinct, what will happen? It will display all the rows in our table, that's 21 rows. But this time we will use another operator, it's called group by. So group by what? We are grouping the data by these two columns or fields. So if we run this code, it's showing again 3 rows. When we use distinct, it also showed 3 rows. Well, this is not the purpose of using the group by, because we can achieve the same result by using the distinct clause. The actual purpose of using the group by is to aggregate the numbers. What aggregation means? Let's look with an example. Select from, let's copy this table name. So we are looking at gender, Now we are going to use an operator. We are going to use a function count. So we are going to count the number of rows. Count. What are we going to count? Is they'll go into a bracket. We are going to count. Let's see what are the other columns. Let's say patient ID. Okay, so we are going to count patient ID, and then let's run this first. Okay, if we run this, as you can see, it is showing an error. It is complaining that the gender is not part of because it's aggregate function, so it's not part of group by clause. So we need to add to group by, and then we are adding the gender there. Now if we run this part, it is showing there are 10 females and 11 male patients in our DIMPAT table, but this column has no heading. For that we need to provide a heading. We can call it either total or count or something more meaningful name. So if we run it again, as you can see, there are 10 females and 11 males. Let's look at another example. You might find it useful. Let's clear all of that. Instead, let's use a different table this time. Select all from our list. Let's use staff table this time. Clinical system, database, schema. Name of the table is dim staff. Okay, let's run and see what's in there. There are 20 rows of data. All the people working for our, let's say, hospital, they are in this table. All the doctors, nurses, radiographers, technicians, everyone is in there. If we want to know how much are we paying to our staff, how we can do that, this will be helpful for the finance department. To do that, we will say select. Okay, we would need this, paste it here, and then we can say, rather than count, we need to use the sum. What are we going to sum? We are going to sum the salary. Say LARY, salary, and again we need to provide a meaningful name. We can say total amount, and if we run that, so this is the figure, is nearly 1.5 million, right? So this the information we can get is quite easily just typing this code. Okay, if you want to know this information for each category of job role, so this is the overall spending we are doing for our, let's say, hospital. But if you want to know how much we are paying to our doctors, how much paying to nurses, radiographers, and technicians, we can do that. Just copy this again, and then what we need to do before this sum, we need to provide role. So, and then as we looked at before, we need to use group by clause, and we need to provide the name of the column. We are grouping this by role. So if we execute that, so now we can look at the doctors are earning nearly 500,000, nurses are 250,000, radiographers 375,000, and also technicians 375,000. Well, next thing we will learn how to sort our data. You know, we are looking at these numbers, but what if you are interested to know highest to lowest, or maybe the rows in ascending and descending orders? How we can do that? We can simply add order by clause, and then we need to provide the name of the column we want to sort it by. So we are sorting by row, and then we need to tell whether it's ascending or descending. If it is ascending, it will be ASC, and then as you can see at the moment, doctor is on top, then nurse, radiographer and technician. I think it's maybe already sorted. It's alphabetically sorted anyway. But what if you are interested to know this in a descending order? At the moment we are only looking at 4 rows of data. What if there are, let's say, 150 rows of data? So it will be difficult for you to sort those rows without the help of the code. So for that we use descending order, DESC, as a short name for descending. So if we run now, you can see the technician goes on top, radiographer, nurse and doctor. So this is how we can do that. We can also sort for our total amount as well. So what we need to do is copy that part and we can paste it here, and then we can say ascending. So we want to know who is earning less amount of money as compared to others. So if we run this, so nurses are earning 250,000, that's gone on the top. If we change it to descending, it will go the other way around. So doctors are earning 500,000. We can also sort the data on multiple fields. I mean more than one column. So let's do that. Okay, delete that and select all. Let's try a different table this time from database, schema, so we are using this fact proc table. Run this. There are 30 rows in this table. So let's sort some data. Let's pick some of the columns which we want to look at. Select and then copy this code, and then let's say we are interested in proc type. We are also interested in proc description, and what else we want to count the number of rows, how many are there. So we will use count on this occasion. So we are counting on dat ID and we give it a name. We can, let's call it count. Okay, so next thing we need to do is group by, and we need to copy both of these columns and paste it here, right? So that's our data, but now we want to sort our data. So for that we need to use order by, and how we want to do that, just copy both the columns and paste it there. Let's try with one column first. We are only doing with proc type. Do that. Under diagnostic, it is the diagnostic displaying first and then the surgery. If we use both of them, so both the columns are in ascending order. But what if you want to see both the column right? That was ascending order. Forgot to add ascending. If you want to see descending order, you would say DESC, descending. By the way, if you don't even use the word ASC, by default SQL Server will sort the data by ascending order, like this. If we add ASC, you can see there's no difference in there. But if you want to look at descending order, then for sure you need to add descending order. Without that, it will not sort the data by descending order. Okay, well, on our screen I'm doing the first one as ascending order and the second one is descending order. If we do that, we can do so. Proc type is in ascending order, diagnostic and then surgery, but proc description is in a descending order, so liver biopsy comes before diagnostic scan. We can do that. We can sort both of them by ascending order like that. So both of them are now in ascending order, or this one can be in descending order and the second column proc description can be in ascending order. So you can do, if we are doing both of them in descending order, then you can do this. So there are different ways. Either you want one column in ascending order, second column in descending order, or vice versa. If you want both the columns in ascending order, then you don't need to repeat ascending and descending. Whatever you put here, both the columns will be sorted by ascending order or descending order. After covering this, another relevant topic is filtering option using having clause. Before that, we did the filtering using where clause, but now we are going to use having clause. Okay, so we have, instead of order by, get rid of that and type having, and now we can use this one, the count of pat ID. And what we are saying here is having count pat ID is, let's say, greater than 2. So what it will do, it will filter out our data. At the moment we are seeing 10 rows of data. So if we run that, it now is showing only 5 rows because it's looking at the count, this column, and if it is more than 2, like as you can see, this is 5, 3, 9 and 5, which is greater than 2, it is displaying on our screen. If you want to, let's try with a different number. If you want to look at less than 5, we can do that. If we run it again, so now it's showing 1, 2 and 3, which are less than 5. We can filter and sort our data at the same time. How we can do that? If we leave this code as it is, after that we add order by and then use the same column, put it there, and then we can say that we are only interested in where the count is less than 5, and also we want to look at the count column in ascending order. So we can do that. At the moment you can see this first 2 rows are 3, 3, then 1, 1, 1, 3, 2, 2. When we will run this, sorry, okay, when we run this, now the data has become in ascending order, the count ascending order, number 1, number 2 and number 3. If you are thinking what is the difference between where and having for filtering, we can run both side by side to see the result. But the thing to remember is we can use where before the group by, as this filters the data before the grouping, whereas having is used after the group by clause. Okay, let's do that. Before grouping we add where, and then we can, let's filter on prop type. Prop type equal to, so we are only interested, let's say, in surgery. And then we group the data. Let's get rid of this having clause in there, and then look at this information. So as you can see on your screen, there are 7 rows, and we are saying where the proc type is only surgery. So it is showing all the records for surgery proc type, and then it grouped the data by proc type and description, and it also provided the total count, how many procedures were done for this proc type and proc description. And then finally it ordered the data by this count, in ones, twos and threes. So let's try to add group by now. Copy this code. Now we get rid of this where clause from here, and instead we are going to add having. So we add this one back to our code, having count to match the previous code. Right, okay, we can give any number. Okay, so less than 5, let's say, and then if we run that, so we are seeing 8 rows on our screen. The count of 5, less than count of 5, there are 8 rows, but we are not excluding diagnostic from our data. We are looking at surgery and diagnostic both, but whereas if we look at our top code, it is excluding the diagnostic and only keeping the surgery. What if we change this number and say greater than 5, and let's see what happens. Right, so the data has changed completely using the having clause and taking out the where clause. So on here there are 7 rows of the data only for the surgery, but this one is not excluding surgery or diagnostic, but only working on where count is greater than 5. So what does it prove? It proves that having works after the grouping, but the where works before the grouping, because it takes out the surgery and then does the grouping and the aggregation. But in having, it is not excluding the data before the aggregation and then providing the information. The proof was in here again, less than 5. So if we run that, you can see it is providing all those 1s and 2s and 3s and not excluding the diagnostic. What if we try to add aggregation to where clause? Let's see what happens. Okay, let's copy this code and paste it again. And this one, if we try to add here, what happens? Now the same, having count patient ID less than 5, we have added to where instead of having. So if we run this code, it did not work. What does it say? An aggregate may not appear in the where clause unless it is in a subquery contain a having clause. Right, okay. So what does it say? It is not possible. One more thing, we can use where and having at same time. Let's see how it works. So for that, let's use this code and copy this one. Make some room at the end. Add there. So we are saying proc type equal to surgery, grouping, and before the order by, let's add having count of having count pat ID greater than 2. So now we are using where and having in the same code. What do you reckon? Will it work? Let's see. Yeah, it does. So what's happening here is in the where clause, it has taken away all the diagnostic procedures, and then the having filter has filtered the data out and only displaying where the count of procedures are greater than 2. So we have only 3. If we delete that part for a second and only run this part, now you can see there is diagnostic and surgery because the diagnostic is number 5 and the second diagnostic is number 9. They should also appear here, but because we are doing undo, we are adding a filter on the where clause where the proc type is surgery. So for that reason, it is taking away last 2 records and only displaying the first 3. So this is how it works. Did you find it interesting? Please note that using a filter with the help of where clause can help a lot when you are dealing with millions of rows. It will filter out all the irrelevant stuff and will work efficiently only on the required data. But please bear in mind, you have to be very careful how you use these filters. If you use these incorrectly, you will not get the desired results. Not to worry, I recommend you to watch upcoming chapters. I will explain best practice to use these filters. Let's move on. There are a couple of things we need to cover in this chapter. Let's delete all this code and start fresh. Select all from database, then schema, and we were using effect proc table. Let's run it one more time. The thing I want to show you that will be quite useful for you is, okay, what if you want to know the top 10% of the data from a table? Although we are working only on a short data which is only like 30 rows, but what if you are working with millions of rows? To calculate the 10% will not be easy for you. So how you can do that? Top 10%, then select all. If you run that, it will provide the top 10% of the data from that table. A useful thing to do with this code is, what if you're looking for the latest procedure in this table? You can do that by running the code, which we are going to run now. Select top 1 all and then copy that table name. And then there's one more thing we need to do. We need to order by proc date. We will do it by descending because we are only interested in the latest procedure which was done Okay, we need to correct the spellings. S-E-L-E-C-T, select. So run this one. Right, so the procedure, where is the date? Right, that's the date. 1st of October 2023 was the latest procedure done, and top 1%. This is how you can find out. If let's say you are working with 250,000 rows, to find that row might be quite time consuming, but with the help of this code you can find that very easily. Similarly, if you want to, okay, copy this code again, and instead if you want to know the oldest procedure and not the latest procedure, only thing you have to do is order by ascending order. If you do that, now the prog date is 1st of September 2001. Right, there you go, easily done. That's the end of chapter 8. In the next chapter we will learn about different types of constraints such as primary key, foreign key, referential integrity, and more. See you in the next video.